Hello, you're welcome to my channel. Now in this video, we want to differentiate the following natural logarithmic functions. All right, good. So in a previous video, I introduced to you the natural logarithmic functions, and I gave you this tool here that we are given y to be ln, okay, where ln is the logarithm to base e. All right, just write it in compact form, ln, which means the natural logarithm, okay, of a function of x. Okay, in this case, it's not just a single x here. We're having a function of x. For example, here it's just a quadratic function of x, or maybe a polynomial logarithmic function of x. Okay, so if you have y to be the natural logarithm of a function of x, then the derivative of that function will give us, now we put 1 over that function of x, all right? Whatever is here, you just put 1 over that, and then you multiply it with the derivative of that inside, all right? Just by using the chain rule. So we'll be using this tool to solve the following, or they are both 3 questions. Okay, now let's go about and solve the first one. All right, good. And now we have the first one, which is the logarithm to base e of x squared plus 1. Good. So in a previous video, okay, we can rewrite this one as ln, all right? Just the logarithm to base e, we write it as ln, and we put it down as x squared plus 1. So ln and the log to base e, they mean the same thing, all right? So that is the y. Good. And now if we want to find the derivative of this function, so I'll put it down, the y, the x, to be, and now from this two here, we have it to be 1 over that function of x, all right? Look at the g of x, where it is. Just look at the position, 1 over that. So here, this position is where the g of x is, all right? So we're going to take 1 over that. So I'll just put it down, 1 over x squared plus 1. And then we're going to multiply that with, well, the derivative of that g of x. So we have it to multiply with the derivative of whatever we put down, right? So it will be the derivative of that g of x, which is the inside function. So you just have to take the derivative with respect to x of that inside, which is x squared plus 1, right? Good. And then this will give us 1 over x squared plus 1, then times, so the derivative of x squared plus 1, well, we just apply the sum rule and the power rule, right? So we differentiate x squared, we're going to have just 2x, and then we add it with, we differentiate 1, we're just going to have 0, all right? So maybe I just add the 0, so we don't even need to add it at all. So all in all, we'll enter with 2x divided by x squared plus 1. And this right here is the derivative of that first function, right? So the only thing is that you will write the logarithm to base e as ln, okay? And you put down the function, bring the function down as a denominator, and then differentiate whatever you brought down, and multiply them together, and that is what you get, all right? Maybe here I would have included a bracket like this to show I'm multiplying everything to the numerator. Okay, here we have the second one to be logarithm to base e, or the natural logarithm of tangent of x, okay? So we want to differentiate this function with respect to x. So let's just go ahead and apply this tool. So we have the derivative with respect to x of the function, okay, to be, well, we're going to put 1 over the inside function. So the inside function is just a tangent, all right? So I'm going to put 1 over that, 1 over the tangent of x, and then we're going to multiply it with the derivative with respect to x of that tangent, all right? Good. So maybe I put it down here well for you. So we have the derivative with respect to x of the tangent of x. Good. And now, I'll just maintain this denominator. Now, the only thing we have to do here is to differentiate tangent of x. Good. So when I was teaching you the derivative of logarithmic function, all right, the derivative of tangent is just secant, the square of secant x, all right? So you just put secant x, and then you square that. So let me just put it down here for you. You put it down here to be secant x, and then we square that, all right? Good. So I'm going to multiply that with, that is just from the derivative, 1 over tan x. And then, all in all, we're going to enter with, multiply this to the top, and then divide it by the tangent, all right? So we're going to have secant, well, secant x all squared. We can still write it as secant square. Then you put down the x, all right? So it does the same notation. Here, it is the secant function that is being squared, not the angle, all right? After evaluating the secant, you can raise it to power 2. It is not the x that is being squared. So you take note of that. So here is just going to be the tangent of x. Good. Anyway, from this, we can still make use of some trigonometric identities. secant square is the same thing as 1 plus tangent square of x, all right? So if you add 1, let me put it down here for you, the numerator now become 1 plus tan squared x. If you add that, okay, you're going to enter with secant squared x, all right? That is just for the numerator. And then I'll put down the tangent of x. So this is just basic trigonometric identity. Okay, if you want to prove this, you can use, let's say, the right angle triangle. And then when you get the tangent, which is just opposite over the adjacent, right? And then maybe you square that and add 1 to that, it will give you the same result as 1 over cosine, which is the secant, after squaring it. Good. Okay, so here we're going to rewrite this as 1 over tangent, all right? Just by splitting the fractions. So maybe I put it down. Let me bring it up. So we're going to have 1 over tangent, then plus tangent squared of x divided by the tangent of x. Good. Well, we know that 1 over tan is the same thing as cotangent, all right? So I'm just going to put down here cotangent of x, all right? And then the square of tangent of x divided by just a single tangent, we are going to be left with just a single tangent of x, all right? Okay, and this right here is a nice place to stop, and that is the derivative of that second function. All right, good. Okay, just looking at this third one, it seems a little bit complicated that we have to apply the chain rule 2 times, all right? But we can still make use of the logarithmic property and break it down a little bit. All right, let's just get right into it. Okay, and now here we have the third one, which is the y equals to logarithm of sine squared x to base e. Okay, so in our next step, I'm going to rewrite this function a little bit, and that will be y equals to, well, logarithm to base e is the same thing as the ln, all right? And then, well, this is just sine square of x, which I can rewrite it as sine x, right? And then I square that. Good. Okay, great. And now from our basic logarithmic property, okay, let's say you have logarithm of something, let's say to base b of a raised to the power n, all right? This right here is the same thing as you bring the n to the front, multiply it with the logarithm of a to base b, all right? Good. Okay, great. So we're just going to apply the property right here. Here, the power here, which is 2, okay, we'll replace the n, and then we'll just bring the 2 to the front and multiply it with the log. And we're going to have y to be 2 times the natural logarithm of sine x. Great. And then we just have to multiply with the function part, all right? To differentiate this function, we can just keep the constant and then multiply with the derivative of that function part. It's not quite that stressful, right? So we're just going to have to differentiate that. So I'm going to put down the derivative with respect to x of y to be, well, the 2 will just be here. Let's not bother about it for now. Okay, so you put down 1 over the inside function, okay? So the inside function is just the sine x. So I'm going to put 1 over that. And then you multiply it with the derivative of the inside function, all right? Just by following the steps we followed previously. So that will be sine x. Great. And then we're going to have, well, let me just do it one after the other. 1 over sine x. Then the derivative with respect to x of sine x will give us cosine, all right? So we just have the cosine of x. Okay, great. And then all in all, we're going to enter with 2 times cosine x divided by sine x is cotangent of x, all right? You know, when you have sine over cosine, it is tangent. So cosine over sine will now give us cotangent, which is the inverse, just 1 over sine over cosine, all right? Good. So that is just by some basic trigonometric ratios. So when you have 1 over tangent, you enter with the cotangent. Okay, great. Okay, that was just it, right? That's just for the 3 questions. Right, thanks for watching. Please subscribe to my channel.